90. A sequence starts with a large square. The length of the square is halved to make a second square. This new square is placed in the top left-hand corner of the original square. The sequence is repeated by halving the length of the new square and placing the resulting square in the top left corner. The sequence is repeated one more time, so there are 4 squares in total. How many times smaller is the area of the smallest square compared to the largest square? To answer this question, we should calculate how many of the smaller squares we could fit inside the larger square, and this will tell us how many times smaller its area is. So of course I could fit a second smaller square next to it, here, like this, inside this size square. But of course this is half of this dimension, so that means I could fit a further 2 squares inside like that. And because this is half of this entire distance, it means I could fit a further 4 squares in a line like so. In other words, I could fit 8 squares in a row, and because this is a square, I could also do that 8 times altogether. 8 multiplied by 8 is 64. So the small square here is 64 times smaller than the area of the larger square here.